We are pleased to present Vivum Computing's work on fusing enhanced autonomy solutions with evolutionary artificial intelligence, sponsored by the Office of Naval Research Small Business Innovation Research Program. In this video, we'll share how our team is addressing one of the Navy's most pressing autonomy challenges, enabling unmanned maritime vehicles, or UMVs, to operate effectively in dynamic, GPS-denied maritime environments. Vivum Computing is a venture-backed autonomous systems company specializing in neuromorphic computing and evolutionary artificial intelligence. Our technical foundation began with a NASA SBIR in 2019, where we demonstrated artificially evolved continuous time recurrent neural networks implemented on field programmable gate arrays. This early work proved that evolved neural networks can deliver compact, energy-efficient, and fault-tolerant adaptive circuits. Since then, Vivum has expanded its scope with private investment and government partnerships, positioning us to deliver a next-generation substrate for autonomy that is resilient, explainable, and low in size, weight, and power. Our expertise is extensive, with leaders in neuromorphic computing, dynamical systems theory, traditional and state-of-the-art AI, embedded systems, and more. The U.S. Navy has made it clear that next-generation autonomy in UMVs is needed, with vehicles that can perform complex tasks with little or no human intervention, adapt to unstructured and uncertain maritime environments, and coordinate as heterogeneous teams performing diverse missions. At the same time, autonomy must operate under strict constraints, including extended periods without communication with an operator, and with unreliable or noisy perception data. Current approaches, largely rooted in conventional AI or deterministic control, struggle under these conditions. A fundamentally new approach to autonomy is needed if UMVs are to fulfill their potential as force multipliers for the fleet. Our goal is to support the Navy's mission through increased unmanned capabilities. While decreasing the need for operator input, the operational stakes are clear. Future UMVs will be deployed in contested maritime environments where GPS or other external localization methods will likely be denied, where communications are intermittent, and where perception systems are degraded by murky water or otherwise noisy conditions. Existing systems are limited in their ability to be deployed for long duration or covert operations in these waters. Our approach directly addresses this gap by delivering a software-only solution capable of maintaining accurate vehicle position, using only simple onboard measurements, while increasing battery life, platform safety, and accuracy in hostile environments. This unlocks operational scenarios where additional sensors are infeasible, unavailable, or, in many cases, too costly. Because Vivum is aligned with the Unmanned Maritime Autonomy Architecture Initiative, our technology enabler can support multiple defense programs and both existing and future UMV platforms. The key to our solution is the Dynamic Neural Network, or DYNE, a first-of-its-kind software-only solution for robust and complex autonomous behavior. Our solution has been developed and validated in 2 stages. As you can see in the image, we first used the virtual hollow ocean simulation environment to establish that our neural networks are a viable methodology for UMV autonomy. In these experiments, vehicles with our dynes were compared against deterministic models currently in use. Our models demonstrated superior safety margins and energy efficiency by learning to manage thruster use dynamically. This work validated neuroevolution as a credible approach to UMV autonomy and control that does not require extensive computation like onboard GPUs, other additional hardware, or massive amounts of curated data. With this, our next step was to integrate Vivum software into existing physical platforms for real-world experimentation. Based on real-world data, we believe that our dynamic neural networks represent a breakthrough in GPS-denied and autonomous navigation. Building on the foundation of our virtual and software-in-the-loop testing, we moved to validate our improved dead reckoning software in a physical system. Here, you can see our technical team using the Blue ROV-2 model provided by Blue Robotics during in-water testing near our headquarters in Bloomington, Indiana, conveniently located near Naval Surface Warfare Center Crane. We were able to successfully replicate the same software-only solution capable of maintaining accurate vehicle position using minimal onboard sensors. consistently outperforming classical baselines and improving on traditional approaches like waypoint following or dead reckoning that are extremely constrained and can lead to asset losses in contested environments. This improvement provides unparalleled autonomous capabilities in motor control and navigation as compared to existing systems. Our team has successfully completed multiple project milestones ahead of schedule, with our virtual testing and validation in Hollow Ocean and software in the loop testing completed in 2025. Hardware in the loop integration demonstrated dead reckoning based on our neural network models in the same year. We are in the middle of firmware and hardware integration with our Blue ROV2 to validate the simulation results in various real environments. Transition beyond this SBIR Phase 2 project will require additional testing and demonstration in Navy-specific environments. We anticipate joint efforts with Navy partners to integrate our autonomy software into operational UMV platforms where it can be validated at sea. Because of our accelerated progress, we are ahead of our program schedule, demonstrating to our government and industry partners that Vivum Computing has already delivered more than originally anticipated and able to compress project timelines, demonstrating both the feasibility of our approach and the ability of our team to execute rapidly on technical milestones. Our technology provides several key advantages over the state-of-the-art. It is software only, requiring no additional sensors or hardware, thereby reducing size, weight, power, and cost. It achieves robust dead reckoning where traditional methods fail, maintaining accurate state and position estimation without external corrections. It adapts to both environmental and bodily dynamics in real time, enabling resilience in uncertain maritime conditions and can generalize without retraining. Finally, it can be deployed across heterogeneous unmanned systems, since the same principles apply to underwater, surface, and aerial platforms. Together, these features provide the Navy with an autonomy solution that is not only resilient, but also scalable and cost-effective. Within the defense industry, Vivum's technology applies across subsurface, surface, air, and land domains. UAVs in particular face severe challenges with GPS-denied navigation without the assistance of computationally and physically heavy vision systems, making a software-only approach highly attractive for any of these environments. While our primary focus is transition to the fleet, this technology also has significant dual-use potential. In the commercial sector, potential applications include infrastructure and offshore energy inspection, environmental monitoring, logistics, and search and rescue, just to name a few. In each case, the ability to perform robust missions in contested locations without costly hardware unlocks new operational possibilities. This positions Vivum's technology at the intersection of defense and commercial unmanned systems markets. We are already ahead of our program schedule, having achieved milestones early and demonstrated rapid progress. With continued support, we will advance to Phase 3 transition, where this software can be integrated into UMV platforms supported by funded programs of record. To get there, we will need investment in testing infrastructure, fleet demonstrations, and partnerships with Navy program offices, prime contractors, and system integrators. Our commercial partners bring the platforms, the operational context, and the pathway to deployment to not only the defense sector, but with offshore energy, security, infrastructure, and survey operations. By working together, we can ensure that this capability is not just a research demonstration, but a deployable solution enhancing fleet operations in the near term. Partnering with Vivum means that your autonomous platforms can outperform competitors utilizing traditional machine learning baselines, showing your customers improvements in power efficiency, adaptability, and fault tolerance. In addition, our flexible modular design integrates faster and at lower cost into your existing and future systems. In summary, Vivum Computing has advanced a novel autonomy technology for UMVs that enables robust GPS-denied navigation through an improved dead reckoning where traditional methods fail. Through our early milestones, we have validated both our methodology and breakthrough capability of our advanced artificial intelligence. Vivum is an agile, veteran-owned small business, and we look forward to partnering with the Navy, other services, and industry to bring this solution to the warfighter, advancing the resilience and autonomy of unmanned maritime systems. Please contact Dr. Derek Whitley or Dr. Justin Slattery by phone or email for additional teaming information. Thanks for your time and interest in Vivum.